Time. It's the most familiar of mysteries. We feel its passage every second of every day, yet pinning down its essence remains one of humanity's greatest challenges. Is time a river flowing from past to future? Or is it an ocean, vast and unchanging? Ancient philosophers pondered time's nature. They debated its reality, its structure, its very existence. Today, physicists grapple with time's secrets using complex equations and mind-bending theories. But the fundamental questions linger. What is time, really? How does it shape our universe and our lives? The answers, it seems, lie hidden within the very fabric of reality. Join me on a journey through time. We'll explore its mysteries and marvel at its power. Let's unravel the enigma of time together. Humans have always sought to measure time's passage. Ancient civilizations looked to the heavens. They observed the rhythmic dance of the sun, moon, and stars. These celestial cycles became the foundation of early calendars. The Egyptians developed a solar calendar remarkably similar to our own. They divided the year into 365 days, grouped into 12 months. The Babylonians, renowned for their astronomical prowess, created a lunar calendar. It tracked the moon's phases and influenced the development of the 7-day week. Timekeeping evolved alongside civilization. The invention of sundials allowed for more precise measurements during daylight hours. Water clocks, using the steady flow of water, provided a way to track time even at night. These early timekeeping methods, though rudimentary, were crucial steps. They marked humanity's desire to understand and quantify time's passage. They paved the way for the sophisticated chronometers we rely on today. Our understanding of time underwent a profound shift in the early 20th century. This era marked a significant turning point in the way we perceive the very fabric of reality. Albert Einstein, with his groundbreaking theory of relativity, shattered our classical Newtonian view of time as absolute and unchanging. His work introduced a new paradigm that would forever alter the course of physics and our comprehension of the universe. Einstein revealed that time is relative. It flows at different rates depending on your motion and the strength of the gravitational field you're in. This was a radical departure from the previously held belief that time was a constant, ticking away uniformly for everyone, everywhere. Imagine two identical clocks, one on Earth and the other aboard a spacecraft hurtling through space at incredible speed. The clock on the spacecraft, moving at a significant fraction of the speed of light, would experience time differently than the clock on Earth. Relativity tells us that time would pass slightly slower for the clock on the speeding spacecraft compared to the one on Earth. This effect, known as time dilation, becomes more pronounced as the speed of the spacecraft increases. This phenomenon, known as time dilation, has been experimentally verified. Scientists have conducted numerous experiments using highly precise atomic clocks to measure the differences in time experienced at varying speeds and gravitational fields. It has mind-boggling implications for space travel and our understanding of the cosmos. For astronauts traveling at high velocities, time would pass differently than for those of us remaining on Earth, potentially allowing for journeys across vast distances within a human lifetime. Einstein's theory also introduced the concept of space-time. This revolutionary idea combined the three dimensions of space with the fourth dimension of time into a single interconnected continuum. It's a four-dimensional framework that unifies space and time into a single entity. This unification allows us to understand how objects move and interact within the universe on a much deeper level. Imagine a vast cosmic fabric, warped and curved by the presence of massive objects like stars and black holes. These distortions in space-time are what we perceive as the force of gravity, guiding the motion of planets, stars, and galaxies. This warping of space-time is what we perceive as gravity. The more massive an object, the greater its influence on the surrounding space-time, bending it and creating the gravitational pull that we experience. Einstein's revolutionary ideas forever changed our understanding of the universe and time's role within it. His contributions laid the groundwork for modern physics, opening up new avenues of exploration and fundamentally altering our perception of reality. Section 4. The paradox of choice, free will versus determinism. The nature of time leads us to a profound philosophical question. Do we have free will, or are our lives predetermined? This question has puzzled thinkers for centuries, and it continues to be a topic of intense debate. Determinism argues that every event, including our choices, is a consequence of prior events and the laws of physics. According to this view, everything that happens is the result of a chain reaction that started long before we were born. Imagine the universe as a giant clockwork mechanism set in motion at the beginning of time. Every gear and cog represents an event or decision, all interlinked and moving in perfect harmony. In this view, free will is an illusion. Our sense of making choices is merely a byproduct of complex interactions within this grand mechanism. Our paths are already laid out, determined by the initial conditions of the universe. Every decision we make is just a step along a preordained route. On the other hand, the concept of free will suggests that we have the power to make choices independent of past events. This perspective views humans as agents capable of shaping their own futures. We are the masters of our destiny, free to forge our own paths. Our decisions are not just reactions to past events, but are influenced by our desires, beliefs, and intentions. The debate between free will and determinism remains a philosophical battleground. There's no easy answer. Each side presents compelling arguments, and the truth may lie somewhere in between. It forces us to confront the limits of our understanding of both the universe and ourselves. Are we merely players in a predetermined script? Or do we have the power to write our own stories? Does the flow of time dictate our actions? Is our journey through life a one-way street, with each moment leading inexorably to the next? Or do we have the power to shape our own destinies? Can we break free from the chains of causality and mold our future like clay in our hands? The answer may forever elude us, but the quest for understanding continues to drive human curiosity and philosophical inquiry. Section 5. Quantum leaps. Time in the realm of the very small. When we delve into the realm of quantum mechanics, the rules governing time become even stranger. Unlike the predictable ticking of a clock, time at the quantum level behaves in ways that defy our everyday experiences. Quantum mechanics describes the behavior of matter at the atomic and subatomic level. Here, particles don't follow the deterministic paths we see in the macroscopic world. In this microscopic realm, the familiar laws of classical physics break down, and time takes on a probabilistic nature. Events don't unfold in a straightforward manner, but are governed by probabilities. One of the most bizarre concepts in quantum mechanics is superposition. This principle suggests that particles can exist in multiple states at once, a phenomenon that challenges our conventional understanding of reality. It states that a particle can exist in multiple states simultaneously until it is observed. This means that until we measure or observe a particle, it doesn't have a single, definite state. Imagine a coin spinning in the air. In the quantum world, this coin isn't just spinning. It's in a state where it's both heads and tails at the same time. It's both heads and tails at the same time until it lands. Only when it lands, or when we observe it, does it choose a definite state. This probabilistic nature extends to time as well. In the quantum realm, time doesn't flow in a continuous, unbroken stream. Some quantum theories suggest that time itself might not be a continuous flow, but rather a series of discrete moments. These moments are like individual frames in a film reel, creating the illusion of smooth, flowing time when viewed in sequence. Like frames in a film, these moments, separated by incredibly tiny intervals, could create the illusion of smooth, flowing time. Each frame represents a distinct point in time, and our perception stitches them together into a continuous experience. The implications of quantum mechanics on our understanding of time are still being explored. Scientists are continually uncovering new insights that challenge our traditional notions of time and reality. It's a realm where the very nature of reality seems to dissolve, into a sea of possibilities. In this quantum world, time is not a simple linear progression, but a complex tapestry woven from countless potentialities. Section 6. Time as a construct of the mind. While physicists grapple with time's objective nature, neuroscientists explore how our brains perceive and experience time. Our subjective experience of time is anything but constant. It can seem to speed up or slow down, depending on a variety of factors. When we're engaged in exciting activities, time seems to fly by. Conversely, moments of boredom can stretch out seemingly forever. Our emotional states also play a role. Fear or anxiety can make time feel like it's crawling. Our brains, it seems, are constantly constructing and updating our perception of time. It's not a passive process, but an active interpretation of sensory information and internal states. This internal clock, however, is far from perfect. It's susceptible to illusions and distortions, reminding us that our experience of time is ultimately a subjective one.